Question 14 and 15 are about linear regression. The question 14 says, given this data set, we were able to figure out the linear regression equation. And suppose the population, we're trying to find the expected population for 1980. You can see this is a correspondence between the x value and y value. Now the y value has to be the population, and the x value should be the number of years. So this is the x, and this is the y. Now the top question is, what is the population, what is the y for the year 1980? Well, it's good that we already have the correspondence equation. This is our year. This is the x value. Okay, so this is all the x value. And then according to the equation for 1980, we have 7.2. But that's not what we're trying to calculate here. We're trying to find the expected population, not the actual population. So using this equation, we're looking at the trend line. This is our trend line. When x is equal to 9080, we're trying to find what is the y value for this equation when x is at, so the calculated expectation. So y is equal to, we're using this linear equation to calculate expected y value, minus 0.5868 times 1980. I need a calculator. Let's do the calculation. I don't have a calculator with me right now. I'm doing the calculation by hand. This may not be a very quick method, but that does save me time going to try and find a calculator in the house. Okay, so far that's what I have. 4 decimal places. Alright, so then we get 1166.93 minus 1161.864. The subtraction is so 5.066, that's what we get. So then this is our calculation. It will be a lot faster if you do the calculation on the calculator. And that will be number 14. Number 15 is talking about the relation between correlation and the regression equation, the connection between them. So suppose the correlation is close to 1. So suppose R is close to 1. All right, and that's normally what we call the almost perfect positive correlation. In that case, you should have a close relation between your scatter plot to a straight line. Okay, that's the situation when R is close to 1. All right, so number 1, it is definitely not going to be a horizontal line because you got a positive correlation. So your line should go from lower left to upper right in your xy plane in your rectangular equation. There is a strong linear correlation, linear pattern, therefore the most likely good model to be used. C, the coefficient is close to the limit. To make decision, that's definitely wrong. Okay, normally this saying that we got a good model actually. When R is close to 1, it's almost perfect positive correlation. We do not have the equation, therefore we cannot see it. Well, when R is almost 1, that's a strong positive correlation, which says we should go ahead and try to find the equation y equal to a plus bx. We got to find what is this equation exactly, because R being that strong, saying that this equation will be very useful, we have to go ahead and calculate this equation. So even though we do not have the equation, we should start calculating and figure out this equation. Instead, you can't just say we don't have the equation, therefore we cannot see anything. You don't have to have the equation to decide if there is a relation. So I would say the correct answer would be B. There's a strong linear correlation between the two variables x and y when R is close to 1. So basically, when R is close to 1, like 0.9, 0.99, or 0.85, when R is pretty close to 1, we say that there's a strong positive correlation. When R is close to -1, we say there's strong negative correlation. When R is close to 0, such as R equal to 0.1, R equal to 0.05, or even R equal to 0.02, and we would say there's a very little correlation, or there's almost no linear correlation. No linear correlation, it doesn't mean there's no relationship, just says no, we can't fit a line. That's what it is. So R basically provided a way for us to determine if you can fit a line, either a positive line or a negative line through your data point.